A decision tree is one of the simplest, most useful models in machine learning. Instead of fitting one complicated equation, it predicts by asking a sequence of simple but cleverly optimized yes or no questions. Let's see how. Here's every day this month described by two features: hours of sleep and cups of coffee. Green days felt productive, red days didn't. The tree's job is to find the questions that best separate the two groups. It starts by testing every possible split for numerical features, sliding a threshold across the data. Each split is scored by how mixed the two sides are, using Gini impurity or entropy. Different formulas, but they usually pick the same split, the one that leaves each side as pure as possible. Here, that question is, did you sleep more than 6 hours? Each side becomes a smaller dataset, and any group that's still mixed is split again the same way. The tree keeps asking questions until the groups are pure, or no split makes them any cleaner. The result is a flowchart where every path ends in a prediction. But real datasets are rarely this clean. If it keeps splitting until every example is perfectly classified, it creates branches just to explain random noise. Instead of learning the underlying pattern, it memorizes the training data. That's overfitting. So in practice, we deliberately limit how much the tree can grow. Before training, you can cap its maximum depth, require a minimum number of samples before making a split, require a minimum number of samples in each leaf, or limit the total number of leaves. Another option is cost complexity pruning. Let the tree grow large, then snip back branches that add complexity without improving model performance enough to keep them. Either way, the goal is the same: a simpler tree that generalizes to new data instead of memorizing the old. So the core idea is simple. Keep asking the question that best separates the data, then keep the tree simple enough to learn the pattern, not the noise.